What we're going to do today, guys, we're going to go through this agenda. I'll give you a little introduction, tell you a little bit about me, just because I like to share. That's why, and just so you know who you're listening to here and who you're talking with. We'll talk about some definitions. The main goal that I want to accomplish today is to give you enough information to buy the components that you would need to put together a simple little prop. So a power supply, a reed switch, maybe a relay, and a mag lock, something like that. So I'm going to tell you enough information to pick out all the right pieces and then to connect them to each other. So I'll give you some definitions to work on that are the background for everything else. I'll tell you about selecting a power supply. We'll talk about inputs, which is reed switches, push buttons, and things like that. We'll talk about outputs, that being mag locks, actuators, and all kinds of fun things. And then once we have all those definitions down, I'll show you how to do some connections. Simple connections will cover connecting one switch to one device, and advanced connections will talk about connecting multiple switches to one device. And then I'll just very quickly give you some options for advanced automation. If you've heard of Arduinos and PLCs, I'm going to talk just for a second about each one because it's really outside the scope of what we're doing, but I want you to be aware of the potential that's out there. So with that, let me just start on my introduction. Most of you guys know my name is Sean, and I created ClueControl. The reason I created ClueControl is because my wife and I, seen at the top right there, we are opening our own escape room here in Massachusetts. It'll be in Framingham, Massachusetts, and it's going to be called the Predaxis Encounter. And as I was going to open that, I really found that there wasn't a control software that did everything that I wanted done. So I created ClueControl. If you guys have been around long enough, you know I created a free version and put it out there for everybody. And then I got lots of requests to add features, which I did, but I couldn't keep it free. So I have a free version and a subscription version. So yeah, that's how I got started. My background has always been involved in creativity. So I started out life as a hardware and software engineer. I spent 15 years designing wireless communication systems and things like that for security systems, factory automation, hospital emergency calls, stuff like that. So I've been a software and hardware programmer. And if anybody knows who those two guys are standing with me, that's Phineas and Ferb, and they are my engineering heroes for anybody who knows who they are. These days, I actually spend a lot of time, my creativity has become less physical and more mental, if you will. So I actually travel around the country and I help businesses to create strategies. I help them to build teams, to create processes that those teams can work in to achieve those strategies. And I do a lot of it using Legos. That's why those Legos are there. I have a lot of activities using Legos. So just to keep people engaged and hands-on and lots of fun. So I love presenting and teaching and coaching and working with people. Now you might kind of wonder how all that led me to an escape room. So this is the garage. The top two and the bottom right are my garage as they used to be during the months of Halloween. And those monster heads that you see, if you look at them, they're sheets of plywood laid sideways, and they're 3 sheets tall. So that's like 12 feet tall and 16 feet wide. At the bottom right, you can see I'm building the false floors to have the people who visit my haunted garage, they walk up over the false floors so I can put effects under it. Um, the bottom left picture there, even when I wasn't scaring people, I was still involved in creating these immersive environments. That's a vacation Bible school where I built what you see there is a 10-foot tall, working, erupting, throwing things out into the audience volcano in the middle of the sanctuary. I was kind of proud when I made the kids in the front row cry. And then in addition to that, my daughters have been suffering through Easter egg hunts for years and years. And these Easter egg hunts take half a day. They involve GPS, riddles, and ciphers. And so when I discovered the escape room industry, I was all in. So that's a little background just to give you a flavor of who I am and where I'm coming from. So let me give you some definitions now. So we're going to start to talk about electricity. And you probably know that water and electricity don't mix. They can lead to bad results. But oddly enough, water is a really good analogy to talk about how electricity works and how it moves. So I'm going to use some analogies about water to give you the idea of some of the terms we're going to talk about. We're really going to talk about two terms, voltage and current, because you need to know those two things to really buy a power supply and wire up a device. Okay, so we'll start with voltage. Voltage is like water pressure. It's how hard the power source is pushing the electricity through the wire. So if you know about water or compressed air or anything like that. It's equivalent to PSI, or pounds per square inch. And it's how hard the voltage is pushing from the source, okay? Just to give you some rough scales, in your household batteries, your AA's, your C's, your D's, all those batteries that look like a cylinder, they all have 1.5 volts, no matter which size they are. The electricity in your house is either 110 for those of you that are here in the States with me, or maybe 220 if we have some of our overseas friends with us. Much higher voltages, and it's enough to get your attention. And then if you really want to see some big numbers, the power lines that go over your head, they roughly have 785,000 volts in them. You definitely don't want to be touching one of those. The 785,000 brings to mind a quick thing I want to let you know, because if this slips out, I want you to be aware. In the electronics world, we use the metric prefixes an awful lot. So actually on that slide before, if I hadn't edited it, it would just say 785 kV, meaning kilovolts or thousands of volts. And then when we talk about amperage and some other stuff, you'll hear me say millivolts or just mils, and we're talking about the milli prefix, which is 10 to the negative third. So 1 millivolt is 1/1000th of a volt. So just keep those in mind as we go through. You don't need to do any particular math or anything, but they're just good to be aware of. When it comes to voltage, there's really two main kinds, and you just need to be aware that they exist. There's alternating current, or AC, and there's direct current, or DC. Most of you probably know that in your house, it's out of the socket in the wall, there's alternating current, or AC. In the States, it turns off and on 60 times a second. We call that 60 hertz, or 60 cycles. And actually, your lights are doing it right now. They're turning off and on 60 times per second, but our eyes are not fast enough to detect it. If we had any of our friends overseas, most likely you're at 50 hertz, so a little bit slower, but still you can detect it. DC is direct current, and it has a positive and a negative side. It's what comes out of a battery, and it's what comes out of most power supplies, and it's what we're going to use the most in the escape room prop building. So DC, those two symbols you see, the one up above, the solid line with the dots, or the one at the bottom that's the plus and the bars, that all means DC. So if you see a power supply with some of those symbols, you can tell if it's AC or DC. The main thing I want you to know about all this voltage stuff and AC and DC and kilovolts and all this stuff, there's one main message that I want you to remember, okay? And that's that the voltage amount and type has to match throughout a system. So if I have this maglock, see down here at the bottom where I've pointed to it, its input is 12 volts DC. That means your power supply must exactly supply 12 volts DC. If you supply less than that, it won't work. If you supply more than that, you'll let the smoke out. And when you let the smoke out of these components, they no longer function properly. So if you look at that 12 volts DC, I'm going to give you guys a quiz. I can't see what you're doing, so we'll just do this verbally here. So I've got 4 potential power supplies to power that maglock. So I'll flip back to the maglock for just a second. I want you to remember this right here, right? It needs 12 volts DC. So if I go back to these power supplies, one of these power supplies will work. None of the other 3 will. And again, I can't see your responses, so just answer in your head, which one would it be? So hopefully you've ruled out the outlet right off the bat, because that's putting out 120 volts, and it's AC volts. So it's the wrong kind and the wrong number. This power supply puts out DC volts, because remember this symbol right here does mean DC, but it's putting out 24 volts, and that would be bad for our poor little maglock who only needs 12 volts. And then the battery, of course, is only putting out 1.5 volts, which the maglock wouldn't even know you were trying to power it. So the right answer is this one right here. It's putting out 12 volts. You can see it says DC 12. It even has a plus and a minus, and I'll talk more about this symbol a little bit later. But there's another part of this power supply that's on here that's a rating, besides the voltage. So we've got the voltage down as 12 volts DC right here. There's this thing right here, this 2A. And what this is telling us is that this power supply can supply 2 amps of electricity. This one can supply 5. It's the wrong voltage, but just note that it does tell you the amperage. It can supply 5 amps. So let's transition real quick and talk about what amperage means so that you understand that part too. If voltage was water pressure, then amperage is the flow of water. So it could be measured in gallons per minute or cubic feet per minute. So it's the amount of water flowing through a system. And in electricity, we call that flow, we call the unit of measurement an amp, okay? And the thing we're measuring is the amperage. So you can see the one on the left, it's got a nice big fat water pipe. So they're saying that that is about 1 amp of water flowing, if you will. And this one that has a narrow channel only has half an amp of water flowing. So amperage is the amount of water that's flowing, whereas voltage is how hard the water is pushing, okay? Now, amperage, there's really 3 different ways to interpret amperage. It depends on what kind of device you're looking at as to how you're going to interpret it and how you're going to decide if it's okay for you or not. Let's start with the device that uses the electricity. So this is your thing at the end. This is your mag lock, your actuator, your LEDs, whatever it is that turns on and does something. This is the consumer of the electricity, okay? So this mag lock, it uses 165 milliamps. Remember that equates to 0.165 amps. So in an end device, the amperage rating is how much it needs from the power supply. It's how much it's going to ask for, basically. Okay, so this mag lock is going to ask for 165 milliamps. Notice, too, that this mag lock is at 24 volts DC and the other one was at 12. Be sure you always look at both of these numbers because they vary all over the place. You can run this mag lock at 12 volts DC or 24 volts DC. Okay? So for a consumer, that amperage is how much it's going to ask for, how much it wants. For a provider, like a power supply like these, this number is how much it can supply if asked. It doesn't mean it's going to force this amount into the line, but this is how much it can supply if it's asked. So this mag lock, if I go back to the mag lock, it needs 85 milliamps at 12 volts. Let's stick with that one. So this power supply can supply up to 2 amps, which if I have any math whizzes on the phone, that's 2,000 milliamps. So this power supply is plenty to drive that mag lock because it can supply up to this amount. If the number of amps on your power supply is higher than what you need on your consumer, that's just fine. Okay, it just means the power supply it's not working all that hard. If the number of amps is lower than what your consumer needs, than what your device needs, then it's not going to work. It'll either shut down or break, one or the other. Now, the third device that could have an amperage rating on it is going to be things that are in between your source, which is your power supply, and your consumer, which is, in this case, our mag lock. And those are going to tend to be things like switches and relays and things like that, okay? On here, the amperage rating tells us how much current can flow through this before it breaks, and you don't want it to break. So this one can supply up to, or not supply, I'm sorry, up to 0.2 amps, which it would have been nicer if they're at 200 milliamps, because that decimal is easy to miss right there. But this one can allow to flow through it up to 200 milliamps. So that mag lock we saw would be it would be okay, but I'd actually shy away from it. If you go over this number, what will happen is you'll fuse the contacts inside the switch, and it'll never turn off again. It'll be stuck turned on. Okay. These switches here, you can see that they can hold up to 3 amps at 125 volts AC. So these are pretty heavy duty for tiny little buttons. So these guys can let a lot more amperage flow through them. So those are the 3 components of how to determine your amperage. Your supplier has to supply a number equal to or greater than what your consumer needs, and any switches in between your supplier and your consumer have to be rated at a number higher than what your consumer needs. Okay, so that's voltage and amperage. That was all the definitions. If you can keep those 2 things straight and have a basic understanding of how they work, then you're good to go. So let's kind of breeze through power supplies. I've really covered most of this, but just to sum it up really quickly for you, there's 2 main power supplies we're going to talk about: batteries and plug-in power supplies. In the escape room industry, I don't think we're going to see a lot of batteries used, but I have helped somebody build a briefcase bomb, and they made it out. They used a battery-powered system. These kind of batteries on the right, not these. Just kind of for reference, the batteries on the left, they all have 1.5 volts, and this is their rough amp hours. So batteries are rated in amp hours. What 1 amp hour means is that this battery could supply 1 amp for 1 hour. This one could supply 1 amp for 2 hours or 2 amps for 1 hour. Okay. These numbers, though, are very, very approximate. And actually, especially in these little batteries, these AA's and AAA's, these numbers are only true if you're drawing out 100 milliamps. If you actually drew 400 or 500 milliamps out of a AAA battery, you'd kill it in seconds. It would just die. So these ratings are actually closer to true at very low current draw. And as you draw more and more current, the battery's going to die faster and faster. We've all experienced that with our cameras and our Game Boys and flashes and that kind of thing, I'm sure. If you're going to go for a more industrial battery, each one is rated different. So here's a 12-volt battery that has 7 amp hours. Here's a 12-volt that has 9 amp hours. And here's a 12-volt that has 18 amp hours. That's a monstrous battery. Usually what's happening is as you get more amp hours, the battery is more expensive and heavier and bigger. So you're trading off runtime for cost and weight. Again, I don't think we'll be building a lot of battery-powered props, but just so you have some general information there. Now let's talk about plug-in power supplies, because I think this is where you guys are going to make your home. This is the one we're going to see the most. I already showed you these two labels before, so we already know this guy supplies 24 volts DC and can supply up to 5 amps or 5,000 milliamps. This one here outputs 12 volts and can supply up to 2 amps or 2,000 milliamps. When it comes to DC, which is what we're going to use, I'd say 95% of the time, there's two things to keep in mind, and that's, well, there's one thing, it's the polarity, and there's two ways you might say it. This symbol right here means that this plug has on the end of it one of those barrel connectors. I'm sure you've seen the ones that I mean. It has a hole in the middle and then a sleeve around the outside. And what this picture is telling us is that the positive is the pin in the middle and the negative is the sleeve around the outside. And sometimes they can be reversed. You could have the pin in the middle is negative and the sleeve on the outside is positive. So you want to make sure that your power supply matches your device. But I will also tell you that it's pretty regular that what we do is just chop that end off and wire it into something. If you just have wires sticking out, it is very, very common, like 98% the rule, that the red wire is the positive and the black wire is the negative. And if you don't have red and black, then you kind of have to guess from there. Which brings me to another little side note real quick. If you're going to attempt any of this, you really need to buy a voltmeter. In my resource thing that I'll send you, I sent a link to like a $10 voltmeter. You really want that. It's going to let you measure voltage and figure out which side is positive and which side is negative. It's going to let you measure switches to see if they're opened and closed and things like that. So if you're going to do any of this, you really want to buy a meter. If it's $10 well spent, because if you don't have it, you're most likely going to blow up more than $10 worth of components as you go along. So that's power supplies, pretty quick and easy. So let's talk about inputs, and then we'll talk about outputs. I'll do both of those before I come back to the agenda. When I say inputs, I mean things that we can use to control something else. So it might be a motion sensor, like on the far left. It might be reed switches, like you see in the middle column there. There's all kinds of different reed switches. There's those glass tube ones at the middle and bottom. There's the surface mount ones at the top and the recessed ones kind of in the middle. There's all kinds of reed switches available. You might have some push buttons in the middle there. Some are lighted, some are colored, some lock when you push them on, some don't lock. There's all kinds of options. And then you might have some toggle switches as seen on the far right. And again, the choices here are innumerable. There's all kinds of switches. One thing that's common across all switches is that they all have, they try to tell you whether they're on or off is really what they're trying to tell you. And they use the terms opened and closed. And open basically means off. It means that the two wires inside the switch are not connected to each other, so we call that open. And closed means turned on, and the two wires inside the switch are connected to each other. So I'll show you a kind of a diagram. And the top two, we would say that those are open because they're not connected. And the bottom two, we would say that they are closed because they are connected to each other. Now, if you've looked at these switches at all, you already know that I purposely skipped over the N, NO and NC. So the N stands for normally. And this is where we run into a three-way problem. The first problem comes before the escape room industry. So if we just count ourselves out, there's already a problem with the word normally. when you talk to an electronics engineer, he will tell you that normally means in the absence of outside influence. So if we're talking about a reed switch, that would mean that normally opened to an electronic engineer means that when there's no magnet, the switch is opened or turned off. Okay, and yet if we talk to somebody who's in the security industry, when they say that a switch is normally opened, what they mean is when the door is closed and secure, the switch is opened. So what they actually literally mean is when the magnet is near it, they call it normally. So in electronics, normally means no magnet, and in security, normally means magnet. Now you throw in the escape room industry to confuse the matter just a little bit more, and for any one puzzle, it could be that the magnet is near the reed switch and it moves away when you solve the puzzle, or it could be that the magnet is away from the reed switch and moves towards it when you solve the puzzle. So the word normally loses almost all meaning in that case. So I'm proposing two terms, and some of you might have seen me already kind of post about this on Facebook, that when we talk to each other, we need to talk about, is the switch open when solved or closed when solved? And that to me has nothing to do with where the magnet is or when the magnet is near it or away from it, because it depends on your puzzle. So I'm going to try to use those terms for the rest of this time, and what it means is that when we solve a puzzle, it opens the circuit, most likely turning something off, and closed when solved means when we solve the puzzle, we close the circuit, most likely turning something on. Okay, so that's things to keep in mind with normally open, normally closed, but do know what open and closed mean, because those are going to come back to haunt us in just a little bit. So let's talk about some outputs. The most common output by far is a maglock. I would imagine, 90% of the props that people are building, they're controlling a maglock, right? It's a nice thing. It unlocks something and lets you open it. A couple little trivia facts about maglocks that not a lot of people know. First off is that they're not ridiculously power super electromagnets that, are going to suck things from across the room. Actually, if you turn a maglock on and you lay a screwdriver against it, you'll barely feel anything. The secret of the maglock is the surface area of that metal plate that it comes in contact with. And it's worth noting that when you do a maglock, that plate has got to be perfectly parallel to the face of the maglock and perfectly aligned. And I mean within a couple millimeters at worst, especially the parallel part. The maglock is not strong enough to suck the plate closed. The plate has to touch the maglock for it to engage properly. So just keep that in mind as you're doing your physical construction. A little diversion there. So maglocks are the most common thing. When you apply power, the plate sticks to the magnet. When you take power away, it doesn't stick. It's really that easy. A couple other things that are popular are strikes, actuators, and solenoids. The thing on the far left is an actuator. When you apply DC power in one polarity, so let's say it has two wires 1 and 2. If you put plus to 1 and minus to 2, the actuator is going to extend its arm. Then if you swap it and you put minus to 1 and plus to 2, it's going to pull its arm back in. So those are really cool because they let you move things. So that's pretty neat. The thing in the middle is a solenoid, and so is the thing at the bottom right. And when you apply power to a solenoid, it either sucks in the thing that's sticking out. So the one in the middle obviously is going to suck in that latch. The one at the bottom right, we can't tell. It's either going to push out that bar or suck in that bar. You can't tell from looking at it. If it's going to push the bar out, they're called push solenoids. And if it's going to pull it in, it's called a pull solenoid. So that's pretty easy to figure out. And then the thing at the top right is called a strike. Probably not a whole lot of these getting used, but it's just worth being aware of them. And a strike is, if you've ever had somebody buzz you in, and you hear that buzzy noise and you can open the door while it's buzzing, that's a strike. While it's buzzing, that little metal piece you see sucks back in and the door can open. Okay, so that's a strike. A couple other things that are worth noting for outputs. One is going to be a relay, and this is going to come back in just a little while. If you've got a switch that does the opposite of what you want, so let's say you have this really cool switch that is opened when solved. And an opened when solved switch turns things off. You can't turn something on with a switch that is opening. But what you can do is you could connect that to a relay, and you could let the relay turn off, which could in turn turn on something else. So the relay lets you use the switch for its opposite purpose. And the other thing a relay is really, really good for is if you have a switch that can only handle 5 volts and a couple hundred milliamps, but you want to power a maglock that needs 12 volts and a couple hundred milliamps, a relay lets you control much larger things than your switch can do on its own. So if you look at this relay, you can pick let's look at the one at the top right. This relay has a 12 volt coil. That means it needs 12 volts to turn on. But then the contacts, these screws, can handle up to 10 amps at 250 volts or 10 amps at 30 volts. So the contacts are super durable on this thing. These relays here, this one and this one, they need 5 volts on their coil because you can see it right here, 5 VDC. So that means it needs 5 volts to turn off or on. But it can control, again, up to 10 amps of 30 volts or 10 amps of 250 volts. So relays are a really nice way to control some higher voltage items. With that said, let me really warn you that I would so strongly caution anybody who's on this particular webinar from cutting into lamp wires and controlling things that run off 110 or 220. Wait till you've built up some experience. So what I would recommend until you're ready to do that is you use this little device. This is called an IoT relay or Internet of Things relay. It costs 20 bucks on Amazon. I'll send you a link to it. And basically what you do is you can plug devices in to these which are turned on normally, or these which are these are turned on normally, and these are turned off normally. And you've got these two little screws over here, and you can send as little as 3 volts or as much as 20 volts through this thing, through your switch, and it'll make these change states. So the normally off will turn on, and the normally on will turn off. So this is a nice, sealed, safe way to control high voltage using some of the reed switches and stuff like that. So please, please consider this if you're going to do high voltage, because I don't want anybody getting hurt out there. One other output that a lot of people like to use is LEDs. LEDs are great. They're low energy, and they can produce some really cool colors. And actually, if you don't know it, there's actually ultraviolet LEDs. So you can use your black light pens and all that. You can light them up with these little LEDs, which is great. LEDs are a little bit more complicated to hook up, and I'm really just going to skim over it and just give you a cheat sheet way to do it. When it comes to LEDs, there's 2 ratings you need to know. You need to know what's called their forward voltage drop, which in this case is 3 volts or 3.2, and how much current they need to turn on properly. In this case, it's 20 milliamps, okay? So just remember that for a second. This particular light needs 3.2 volts and 20 milliamps. There's a really cool calculator, and you know what? I just realized I forgot to link this in my resource sheet, but I'll add it in later, or you guys can jot it down while I'm talking. When you go to this website, you tell it what your power supply is rated at. So let's say I've got a 12-volt power supply, and you tell it what's the forward voltage of your diode. In this case, it was 3.2. That's what was on that page before. How much current it needs, and how many of those LEDs you want to turn on. So I want to turn on 5 of them. So it tells me to turn on 5, here's how you need to wire them, and here's you need a 120 ohm resistor here and a 330 ohm resistor here. And I can't scroll because this is a screenshot, but they gave me more down here, more options of different ways to wire it. So there's a lot of math and such that goes into this. If you really want to do LEDs, just go to this site, plug in these values, and pick one of these things it says. Okay, that's really the easiest way. So that's all of our outputs. There's some nice options. You can find some things to play with, and you can make some pretty cool things with that variety of inputs and outputs. Okay, so now let's talk about how we hook them all up together. We're going to start with a simple connection of one switch powering one thing. So this is real simple, right? I have this switch, and it's either open when solved or closed when solved. It doesn't matter, but whatever the switch is, I'm going to wire one leg of my power through the switch. In this case, I chose the 5-volt power side, the plus side. It goes through the switch and then to the thing I'm turning on, whether that's my maglock, a strike, the IoT relay, whatever it is you're turning on. And then the other side of that same output device is connected to the other side of the power supply. So only one side of the power supply connects to the switch. Now, The thing with the switches is if you have a switch and it is going to be closed when solved, all that can do is turn stuff on. You can't turn something off with a closed when solved switch. The same thing with an open when solved switch. All open when solved, oh no, wait, I said that wrong. Closed when solved is going to turn something on because it's going to close the circuit when they solve the puzzle. And open when solved is going to turn something off. It's going to break the circuit when they solve the puzzle. If you need to swap that around, then you need one of those blue relay boards that I showed you a picture of. So now what you can do, the relay board itself gets power. So my power supply is connected to the power for the relay board, and then ground is connected to the relay board. And then my either open when solved or closed when solved switch plugs in here. And then on the other side of the relay board is where I plug in my device. And notice also I changed the power supply. So this switch can only handle 5 volts, and this relay board needs 5 volts. But over here, I'm actually controlling 12 volts. So what I did here is I've got 12 volts connected to my device, whatever it is, my mag lock, my strike, or my relay. I guess IoT relay wouldn't really be a good thing to put there because you could have done that with the 5 volts. So ignore IoT relay. So mag lock, strike, whatever you're putting out here, actuators. And then the other leg of my device goes to the common on my relay, okay? And then this NC will either normally closed will connect to ground or normally open. Basically, without explaining it too much, pick one and try it. If it works the opposite of the way you want, pick the other one. So if I wired it just like I showed you here, and it did the opposite, when I solved my puzzle, this thing turned off, and what I wanted was for it to turn on, then instead of putting my ground on normally closed, just move it over to normally open, and it'll reverse how it works, okay? So that's really straightforward. On my next pictures, I'm going to only show this top thing right here, but know that every time you see this, you could substitute this whole thing down here if you wanted to, okay? So you can switch that out as needed. So let's talk about using multiple switches at a time. If you have multiple switches, they're going to be closed when solved, and what you want is for your players to have to solve all the pieces. So I've got 4 switches. So what I want here is I want them to solve all 4 things. I want them to find 4 objects with magnets in them and put them in the right places. You're going to wire these in what we call series, and it's series because the end of one is connected to the other. So this switch is connected to power, and then the out of this switch is connected to the in of this switch. And then the out of this switch is connected to the in of this switch, and so on. When they solve all of these and close all 4, then the electricity can flow from here through all the switches and into my device, whatever that is, my IoT relay, my mag lock, whatever it is, okay? So if you have multiple inputs, if they're going to be closed when solved, you want to wire them in series like this. If we're going to have switches that are open when solved, maybe these are pressure plates, and we want the players to have to stand on all 4 of them, and the switch is open when they stand on them. Then you're going to wire them in what's called parallel. So notice now that all 4 of them have a power supply, and all 4 of them connect to our device. When players open all 4 switches, then this device will turn off, whatever it is. Okay? If they only open 2 of them, if they open these top 2, the electricity can still go down through this switch and up here, so it won't turn off yet. They'll have to activate all 4 open when solved switches to turn it off. Okay? Now, it is certainly possible to do combination circuits where you've got multiple open when solved and multiple closed when solved, but it just gets a little bit tricky, so you just have to think your way through it, and it's outside the scope of where we can go today because our time's already coming to a close. But just know you can do even more. But I think with being able to do some series or some parallel circuits, you can already make some really cool puzzles on your own for a pretty small investment. Now let me take you through some advanced options really quick. I'm going to just give you some quick things for advanced automations. I'm going to give you 3 potential ways that you could do advanced automation. I'm going to give you easy, medium, and hardcore. The easiest way you could do automation yourself is what's called Z-Wave technology. And this is all wireless stuff. You can buy it at Home Depot, Amazon, Lowe's, and stuff like that. And basically, you control these devices. You've got little switches that they're like security sensors. They're like reed switches, but a little bit bigger. And through ClueControl, you can tell it when this reed switch opens, I want you to turn on these outlets and turn off this outlet, turn these on and turn this off, and turn on this light bulb. So you can do all kinds of cool stuff, and there's no programming, no coding. You set up the network, which is kind of pushing some buttons and watching some lights blink, and then ClueControl from there will let you add a lot of automation. And the other cool thing is you can monitor when your players finish puzzles and what their timings are, and you can give them reports on how they compare to other teams, stuff like that. So that's easy automation. If you want medium automation, then you can go to what's called a PLC, a programmable logic controller. And these guys at Velocio make a really cool one that starts at like $50, which is really nice and low cost. For $60, you get six inputs and six inputs and six outputs, something like that. Yeah, I think you get this side, six inputs and six outputs. Now these need some programming, but they can make some moderate decisions. They can do some timings. And you program them using visual drag and drop with some boxes and words, and it takes a little bit of thinking through it and logic, but it's not like coding. You're not typing anything. You're just dragging and dropping boxes and connecting them. It's really well done. I've played with these things a couple times, and I'm pretty happy with them. And again, these can communicate with ClueControl. We can automate things through the software for you. And then the hardcore way, and I'm sure most of you guys have heard of these already, is the Arduino. Arduino can make ridiculously complex decisions. You can talk to RFID readers. You can do all kinds of really cool stuff with the Arduinos. You do need to learn to program in C++, which is not hard. There's lots of online tutorials and online help available out there. And again, these will let you connect with ClueControl also. For those of you who don't know, just a couple seconds on ClueControl. It's a software that we built that, again, I built it for my own escape room because I didn't think there was anything out there that did what I wanted. So you can fully customize the display that's in the escape room. You can use clue counters. You can have your logo on there. But what I love the most is the automation. You can control your whole room and get a lot of really cool automation and advanced features. Everybody gets a 30-day trial. If you sign up before the end of March and use the code GURU, you get $10 off for your first 3 months. Okay, so you can put that in there. Another thing we have at ClueControl is if you want to build the props, but you don't want to learn to program an Arduino or a PLC, we can either build an Arduino in a box with screw terminals, and we'll tell you what to connect where, and then you build your own prop, or we'll just write the code for you and send it to you. We do consulting that way. So if you need help, the top line right there, this is the thing. We're just here to help. We really want to help build up the escape room industry and let everybody be successful. So just reach out to us for whatever you need. If you haven't downloaded it, download this resource sheet. It's got links to different things. Here's that $7 voltmeter I was talking about. Here's the IoT relay. Most everything I showed you, I give you a link to it. You can go check it out, buy it if you want to, don't buy it if you don't want to. I really encourage you to get a meter if you're going to do any of this work, just to save you and your electronics from being blowed up. And then stop by our website, check us out, drop me a line on Facebook, drop me an email. I don't think I put it anywhere, but it's just feedback@cluecontrol.com. Yeah, reach out to us, and if we can help you in any way, we're certainly happy to do it. So I hope that inspires you guys, gives you some ideas and some basic thoughts on things that you might be able to wire up and control. And with that, Ron, let's open it up for questions. If you've got any there, you can throw them at me, or we can talk through them, however we want to do them.
Yeah. So Chris Hyder was asking about the board with the 5 volts. If you can just remind us about it, Sean.
Yep. So he said the board with the 5 volts, and then the output needed to be 12. Does that mean you use 2 different power supplies and outlets? That is absolutely correct. So if you had a prop and you needed a 12-volt mag lock and a 5-volt something else, that means two plug-ins, 2 power supplies. It is less than ideal, but it happens relatively frequently. So it just depends. If you can get your reed switches so that they can handle the current of the mag lock, then you'll be better off. If you find reed switches that are not rated, assume they can't handle the current. Just you need to assume that. What types of cables? So Cat5 and Cat6 are generally data cables. They could handle a couple hundred milliamps at 5 or 12 volts and they'd be okay. They're usually a small gauge wire, like 24 gauge wire. wire gauges are funny. The smaller the number, the bigger the wire. So a 14 gauge wire is bigger than a 24 gauge wire. Um, I would suggest that for most things like this, you buy some 22 gauge wire from a security house. You can buy 22/4, which means 22 gauge wire for conductors is generally pretty cheap. Um, you want stranded wire. If you get solid wire and you bend it back and forth too many times, it'll break. So some 22/4 stranded is pretty inexpensive and not too hard to come by. If you got Cat 5s around, you could use them. The Cat 5s tend to be solid, so the ends will break off more easily. So not my first pick, but if it's what I had, I'd probably use it. Okay, so they asked about ClueControl. How does ClueControl connect to an Arduino? Do you need a Wi-Fi shield? ClueControl connects to Arduino and to the PLC using an industrial standard called Modbus. And so there's three choices, but really Wi-Fi is one. So if you pop the Wi-Fi shield on there so that the computer and the Arduino are on the same network, then that's one way. I would always wire if it's at all possible. So if it's at all possible, I'd actually put an Ethernet shield on it and then connect the Ethernet shield to the computer because wired is always better than wireless. I've worked in wireless for 20 years and it's how I make my living, but I'll tell you it's never as good as a wired connection. So wire if you can. If you can't, then Wi-Fi. Um, and actually, um, you can also connect. There's a way to do it even without using Ethernet. We can do it. If there's only one Arduino, we can do it more directly through a serial port. For resetting props, a couple different things. I mean, if all you're trying to do is reset your props and not monitor them, if they're Arduino powered, again, we can connect them with the Arduino. But I think maybe for just resetting, the Z-Wave might be a good answer because you could plug your props into Z-Wave controlled outlets and just send a signal that turns all those outlets off and turns them back on. So that makes for a quick and easy reset. And it's not too costly. The Z-Wave is a little more costly than, say, an Arduino because the Z-Wave, I think those devices are 20 bucks, 30 bucks each, whereas an Arduino is 10 bucks. Do you recommend using a switching power supply is another question that's here. You can hardly buy anything that's not a switching power supply anymore. Even these little cheapy power supplies, I don't have a whole picture. Well, here, let me show you on my resource sheet. Even this little cheapy power supply up here, $11 for a 1.5 amp, even that's a switcher. Any more, they really don't make brute force power supplies much anymore, which that's the opposite of a switcher. A switcher monitors its own voltage and regulates it as needed. A brute force one, it uses brute force. It assumes a certain input voltage and it assumes a certain current. So yeah, I would definitely use a switcher, but I think that pretty much all of the things you come across today are going to be switchers. So yeah, video players. Somebody asked what would you recommend for a video player, and Arduino doesn't have the horsepower to play a video. You can get a VGA shield for it. If you can dig up an old VGA monitor, then you could do that. But if you actually want to play a video, I'd go to a Raspberry Pi, which for those of you not familiar, it's kind of even more complex and yet more powerful than an Arduino. It's kind of like a whole laptop on a circuit board about the size of an Arduino. It has an HDMI port, it has USB ports, it can actually run Windows. So yeah, I would go to a Pi if you're going to try to do an embedded video player and you don't want a computer in there, then a Pi is the way that I would go with it. Those take even more. Those are extra hardcore compared to Arduinos, but there's still a really good online community of people that will help you and places you can find resources and tutorials and stuff like that. So yeah, the Pis are good too. I think you can pick up a Pi. I want to say you can pick one up for 20 bucks. So it's still not breaking the bank. If you were to control your props with an Arduino, would you locate that in the control and run your wires to your props, or should the Arduino be located near the props? So that's an interesting question. What you're really hinting at is what we call centralized control versus decentralized control. Some of the things that come to my mind is how modular do you want your room to be? So you could take one Arduino and control, 15 props, To do that, you'd run wires from those props all back to some central room. The advantage is there's only one Arduino. The advantage is there's central troubleshooting. The disadvantage is if you want to swap out a prop, you've got to rewire it and things like that. That's called centralized control. Decentralized control is you'd put an Arduino in each prop, and each prop would be self-contained and make its own decisions and do its own thing. Um, so some of it just depends how complex your props are and what you're trying to do. I always tend towards decentralized. The Arduinos are $10 a pop, so I'll put a couple in a room and build props independently. But if I have, so my room's going to have 4 RFID readers that are far enough apart that I want each one to have its own Arduino, but then they're going to talk to each other and coordinate with each other, and they're going to talk to ClueControl, of course. So I tend towards decentralized, but centralized isn't out of the question. If you go centralized, that's more what a PLC is meant for. This guy here, this is more meant for this because see, you can get up to 18 inputs and 18 outputs, and this is the baby version. They sell a bigger one with many, many more inputs and outputs. So if you're going to go centralized, maybe a PLC is more your way, but I tend towards decentralized. What's the easiest way to activate a sound card? I've actually done several of these for different escape rooms here recently. For the Arduino, you get a serial, what's called a serial MP3 player. It has 3 little pins that connect to the Arduino. You plug an SD card onto the back, and it has a headphone jack built into it. Um, you can get them for like $12 on Amazon, but they take forever to get here because they come from China. So I order them 25 at a time or something like that. But yeah, Arduino is the easiest way to do that. You just did the same one again about the sound. To me, the easiest way to do a sound outside of ClueControl is going to be an Arduino with the serial MP3 player. But so that's another thing. I mean, I don't. I'm trying not to advertise here, but if you want to trigger videos and sounds and all that stuff, that's all what ClueControl is meant for. You can just do it um, with software in ClueControl. So they're asking about magnets to use. The ones they come with are a good starting point. Um, you got to be careful. So there's magnets out there called neodymium magnets, and I might be saying that wrong, but they're called rare earth magnets, and they are really, really strong. They're super cool little magnets. I love magnets. I think they're magic. Um, but you can bend the internal pieces of a reed switch if you use a magnet that's too strong and you get it too close. So I would try to stay with the magnets they come with if at all possible. If the problem is that the magnet, you can't get it close enough to the switch to activate it, then 2 things. One is you could try a rare earth magnet, but make sure you don't get it too close because you can break your reed switch. But the other thing is there are reed switches called wide gap reed switches, and those are meant for when the magnet can't get super close to the switch. So they come with a stronger magnet and they're calibrated to deal with that. For those who decentralize Arduinos, meaning one for each prop, how do you connect each to ClueControl and Ethernet hub? Ethernet hub is exactly the right answer. Just you're gonna run a Cat5 Ethernet a network drop to each one, or if you want to put in Wi-Fi, you can do that. They just have to be on the same network at the end of the day. I mean, if you guys have more questions, you can email me or hit me up on Facebook. I'm always happy to answer questions.